Thank you for my other co-organizers for encouraging me to do this. And I'm going to apologize to all of the other workshop people and speakers for talking about this today, but it's not my fault. I was supposed to talk about this Friday, and it would have been a much better talk Friday than today, and you'll see why in a minute, because I'm about to sabotage all the other speakers. Let me say a little bit about my path, because it's very non-linear. I started out as just a straight up pure mathematician and hadn't touched a computer in many, many years for anything resembling coding. But I work at a very small college, and I started getting involved with mathematical illustration, which involved reteaching myself how to code, which I hadn't done since I was in high school, around 2012. And so I did a lot of 3D printing and coding, and my college is small enough that there was a crush of students wanting to learn some computer science, and I was the only faculty member at my college who knew how to code at that time. And so I got pressured into starting to teach computer science and data science courses around 2019. And slowly over the next 6 or 7 years, transitioned to, that's all I teach now. I don't teach math anymore. I just teach math and computer science. By 2022, I was teaching a lot of machine learning and artificial intelligence courses, which was right before ChatGPT came out, which was at the end of 2022, when the crush of students wanted courses in artificial intelligence because of ChatGPT alleviating some of the pressure on computer science and data science. And then I got more and more into artificial intelligence, and now I teach a lot of some advanced courses in artificial intelligence. Like last year, I piloted a course in reinforcement learning. So just slowly transitioned, and that's pretty much just what I do these days. And so I still go back to the old topics. I still think about low-dimensional topology, but now I often think about these things in light of how can we use some of these more modern tools in artificial intelligence to aid us in doing some of the work I used to do much more. And in particular, mathematical illustration. I've thought a lot about how do we use artificial intelligence to do some work in mathematical illustration. Most of this is just exploratory. I spend a lot of time just playing. And so I'm just going to demo today mostly a bunch of different ways to use artificial intelligence to do some sort of mathematical illustration using a variety of different tools and models and model providers. There's a lot of reasons not to do what I'm about to talk about. Many people have very legitimate concerns with environmental concerns, copyright concerns, legal concerns, ethical concerns. Those are all absolutely legitimate concerns. I don't have any issues, and I don't tend to get into a lot of arguments with people who object to it on ethical basis or not. We can talk about it. I tend to end most of my talks about 10 minutes early so that there's real time for discussion, for me talking to audiences. I've talked to lots and lots of audiences about artificial intelligence, about all the issues involved. Usually those issues are not black and white. It seems like the environmental concerns in particular are very significant, but there are some reasons why maybe it's not as big of a concern as some people make it, although there are a lot of real concerns. So I will probably do that today, although I've started already short on time. I'll try to end about 10 minutes early so we can have a discussion if anybody wants to talk about artificial intelligence, any aspect of artificial intelligence. Doesn't have to be related to illustration. For today, that second point is the one I want to focus on. Is one of the biggest reasons not to use artificial intelligence is because I do think it's a real problem in colleges and high school. I think AI, modern AI tools, large language models are one of the best tools humanity has come up with for acquiring knowledge in the sense of learning facts, learning, you want to learn the theory of relativity or whatever, you just mentioned it, or some aspect of history. It's nice to be able to dialogue with a large language model about something factual, but not something skill-based. So if you want to acquire certain skills, coding skills, thinking about a certain topic, illustration skills, I think artificial intelligence is one of the worst tools humanity has come up with, because it does the work for you. And of course, if you have a machine doing the work for you, then you're not doing it. So I'm going to encourage everybody not to use anything I'm about to talk about until after this week. So one of the demos I'm going to do is going to be a shader toy demo. Sorry, Steve. And so don't do what I'm about to do with shader toy. I was supposed to do this Friday, not today. So just resist the urge, but because you'll see the temptation's going to be there. Because you're going to think of cool stuff to do, and you're going to get stuck, and then you're going to want to be tempted to use AI hopefully after I show you things. Because there's a lot of reasons to embrace it as well. Once you've acquired those skills, then it's an amazing tool. A lot of people describe it as their superpower. Once you know how to code, then having it code for you, now you can code many, many times as fast. Instead of a coding project that maybe you could have done in a week, you can ask Claude to do it in about 5 minutes for you. And many, many software engineers, not just software engineers, but many people from different disciplines have really described it as their superpower. But those are generally people who already know how to do it. It's just speeding up their workflow. So that's one big reason why to embrace artificial intelligence. But again, you've got to acquire those skills first before you ask AI to do it for you. So for this week, since this is a learning week, try to avoid using it. Saves a lot of time. The other thing I find constantly is when I do ask AI to do something for me, sometimes it does it in a way that I wouldn't have done. And if you really take the time to see what it did for you, then you learn a lot. So I think there's a lot of reasons to use it as a learning tool, even if you have those skills. You can acquire new skills by unpacking what it did for you. All right, so let's talk about some ways to use AI to do mathematical illustration. This is a non-exhaustive list. I gave some of you, I think it was about 10 people in this audience who are at a similar talk I gave last summer at ICERM. And I went through each of these and did a little demo of each of these. I'm going to focus on something a little bit different today. So one way is to just most of you, I hope, many of you, if you've ever dialogued with a large language model, you may have asked it, hey, make me a picture of whatever. And so you can describe some kind of mathematical thing and say, hey, make me a picture of this mathematical thing. And their abilities to make mathematical illustrations have improved since they came out. 2022, it was fairly terrible. Today, you can ask it for some fairly detailed mathematical illustrations. You can ask it to write code to generate mathematical illustrations for you. So you can get some fairly precise images out of an AI image generator just by describing it and asking it, and you're done. And that's the end of it. Of course, you lack a lot of control when you do that. The control has gotten a lot better. Another thing you can do is you can ask it to generate the geometry. Rather than generating the image pixel by pixel, you can ask it to generate something that's more mathematically precise, like the code for an SVG file. And then you've got more finer control, and it can generate things that way. And again, I gave this talk last summer, and I demonstrated each of these. Another thing is you can vibe code an app. Vibe coding is a new term. It's about a year old, coined by Andrej Karpathy. And it's a way non-coders can interact with coding environments to create software, and you can create your own mathematical illustration software. So something like Cinderella now is capable, you can vibe code something along those lines just by describing the app you want to create. And there's varying degrees of success to which it can make apps like that, but it's getting really impressive just in the last 2 months, I'd say, since Claude Opus 4.5 came out. You can vibe code something about as complex as Cinderella at this point. So there's a lot of ways you can use illustration. The one I'm going to focus on mostly today is using other packages, kind of standard CAD packages like Shader Toy that we're about to see, or Rhino. A lot of people in this room are Rhino users for mathematical illustration. That's mostly what I use for mathematical illustration. I know there's people like Laura Tallman who's done a lot of work with OpenSCAD. I'll demo each of these. Blender, maybe you're a Blender user. These are all graphics packages, CAD packages that have a scripting interface. So you, within this larger package, you write some code to drive the illustrations. And now that AI has gotten better, you can tell it what package you're using and ask it to write a script in that package. And I have yet to find a package that stumps it, that it says, I don't know how to use that package, essentially. So you can say, write a script in Blender to do whatever, and it will write the script for you, and then you copy and paste it into Blender. Or write a script in OpenSCAD, and it can look up the API. If it doesn't know it, you can enhance these tools if you need to, but generally I haven't found a case where I need to. So the general technique, and this always works is in quotes, but it's universal in the sense that it seems to be package independent. You can do this with Blender, you can do this with OpenSCAD, you could do this with Rhino. It's just ask it, just go to your favorite large language model, ask it to generate the code for you, describe what you want, and then copy paste that code into the CAD package. So this is kind of a universal technique regardless of the CAD package, and I'll demonstrate this in a minute. The problem with this, and this is really what I'm going to focus on today, because any of you have actually done this, you will immediately run into the following problem, which is that it doesn't always work. Sometimes there are errors, in which case now it lacks that error awareness, because you're just copying, pasting it over, and then it fails, and then you get an error message, and now what do you do? So one thing you could do, the easy thing to do, is to just take the error message, copy and paste it back to the language model, ask it to evaluate the error and regenerate the code, and then you end up going back and forth, and you get a lot of context switching issues, which are psychological issues. There's a lot of just inefficiencies and inaccuracies. So creating that feedback loop is, I think, the key to really unlocking the power of using artificial intelligence with mathematical illustration. So I'm going to focus on that a little bit more today. How do you create this context awareness within whatever CAD package you're using? Some packages you can, some packages you can't. So, but let's just start with just a little demo here. I'm going to just sort of demonstrate just this basic technique. Just go to any of the, and again, I'm going to try to make this somewhat platform agnostic. So I'm going to do a ChatGPT demo, I'm going to do a Gemini demo, a Claude demo. You'll see these different packages and different ways to use each of these packages. So we'll start with ChatGPT. I have the ChatGPT app on my computer, but you could just go to the ChatGPT website and you could just type in, write a script for OpenSCAD. Just again, I'm going to keep it also CAD package, some agnostic. So we're going to see a lot of CAD packages and a lot of, oops. I'm just going to literally copy paste this prompt. It says, write a script for OpenSCAD that creates a thickened trefoil knot. So I'm just going to copy paste that over into ChatGPT. Oh, what happened? Uh-oh. What did I do? Still not there. How did I do that? Hold on. Displays. I should be able to mirror displays. Mirror. Did that do it? Yeah. Better. Okay, there we go. So it's I don't know, the font got real small, but I just copied paste that prompt. It says, write a script for OpenSCAD that creates a thickened trefoil knot. And hit enter, and it's going to think a little bit. It says, here a self-contained OpenSCAD script that builds a trefoil knot as a smooth tube by sweeping circles along a trefoil parametric curve using hull between consecutive cross-sections. Just if you've ever played with OpenSCAD, so OpenSCAD, let me just flip up while it's generating this code, which will take about a minute. So it just generated a whole lot of code. And it's done. I'll copy this code, and let's go over to OpenSCAD. Here's OpenSCAD. So OpenSCAD is a fairly simple parametric modeler. Unlike a lot of the other CAD programs I'm going to show you, there's no drag and drop capability in OpenSCAD. OpenSCAD, you create geometry with code, and that's it. You can't select points and move around. You can't, build a circle. You can't build a tube like you can in something like Rhino or Blender. All you've got is code, and the API is fairly primitive. So if you go to the OpenSCAD website, you can see the documentation, and there's no obvious way to make a tube around a curve. It turns out you can do it, but if you read the documentation, it's terrible. I thought it was actually impossible to do that, but I was wrong until I just tried this experiment. So I'm going to copy paste this in. Now, when I did this at home, I got an error message. The code it gave me didn't work, and then I had to copy paste the error back into ChatGPT. I don't know what's about to happen, because every time, one of the features of all these large language models is they're a little bit stochastic. So every time you ask it the exact same prompt, you may get a different answer. So this may or may not work. And if it doesn't work, it'll be a learning experience, and we'll see what happens. So yeah, we need Laura here. And I'm not an OpenSCAD user, so I don't even remember how to do this. Is anybody an OpenSCAD user, I think? The 2 arrows?
2 arrows, I think.
This one here.
Yeah. I think it's fast.
There we go. Okay. Yeah. Thank you. Yeah. So it did it, and if you know any coding platform, you can generally decipher the code. So I write almost all my code in Python. OpenSCAD has its own scripting language, but just if you know how to read Python code, you can decipher this pretty easily. You can see the main features here. One of the features of these large language models is they tend to, if anything, over-document their code, but that's a good thing. So you can see the documentation there, standard trefoil parametric curve, x equals 2 plus cos 3t times cos 2t, y equals 2 plus cos 3t sine t. So this is, if you've ever actually sat down and written down a parameterization for a trefoil knot, that should look familiar. And then it's actually doing this in a different way than it did it last time, but that's fine.
Did you say how it's doing it now and how it's doing it differently?
Yeah, I think last time it did it by piecing together little cylinders, and it's not at all clear from the documentation how you make a cylinder, because there's no cylinder tool. There's a sphere tool, and you can control the number. It's a polyhedral approximation of a sphere. You can control the number of faces longitudinally and meridianly around the sphere. And if you make the faces, if you put one, so I forget this right, if you make it one meridional face and many longitudinal faces, you end up with a little cylinder. And so and then you piece together a bunch of those, and then you take the convex hull of those, and you get a smooth trefoil knot.
That's what it did this time?
That may or may not be what it did this time. I'd have to read it to see. I don't think that's what it did this time. I think it's doing something else. It says module section, RP, ROTC from direction. Oh, there it says cylinder. Yeah, I'm not sure if it did that this time or not. But it's not at all clear from the OpenSCAD documentation. I learned that by reading this code, essentially, or whatever code it gave me when I did this at home. So, yeah.
So it says David Friendly not off the top. Is this because it knows you?
Probably. Where?
Top line of line 2 of the text says David.
Oh, back. Oh, David Friendly knobs up top. Yeah, right. So that came from the ChatGPT code, and I have a ChatGPT account, and so it knows some things about me. And one of the features of these models is the more you interact with them, they remember your previous interactions. You can turn that off. Some people are uncomfortable with these companies knowing stuff about them, keeping track of their private data. Some people like that because the more it knows about you, the more it can tailor its responses to you and your technical level of expertise. So if you don't want it to over-explain code to you, then you might want to teach it how much code you know how to write, and then it knows things about you. So there's, it's good and bad about that. Yeah?
If you see some artifacts that you don't like, when you ask AI to fix it, you don't fix it.
Yeah, right. So now, so there's a couple things you can do now. So now I can follow up with this and say, modify this code to make it a 5/4 torus knot instead of a trefoil knot, which is a 2/3 torus knot. Or make the tube thicker, things like that. Or if there's something, make it red instead of yellow or whatever. And then it will then rewrite the entire code, or it will tell you which lines to modify, one or the other, depending on how you instruct it.
I also did artifacts and I just said it looks ugly and now it works.
Yeah.
Yeah, sometimes you could just say, make it better. Yeah. Other questions on this? All right, so let's move on. So,
I have a question, Dave.
yeah,
Are we all doomed?
are we all doomed? We can talk about that. Ask me that in 10 minutes. Are we all doomed? Maybe.
We'll be doomed in 10 minutes.
Yeah. Okay. As I said, the issue is context awareness. So it didn't happen before, but it did happen when I did that at home. So when I did it at home, it didn't work, actually. And the error, I can tell you the error it made, was it mixed up degrees and radians. So it's not perfect. It gave me measurements in radians and was expecting degrees or vice versa, I can't remember. And so I copy-pasted the error that it gave me from OpenSCAD back into ChatGPT. It figured out the error, read the error, it figured out what it did wrong, regenerated the code, and then it worked, right? But that is a pain, and that problem, when you're dealing with thousands of lines of code, that problem can be really significant. Copy pasting error messages back and forth and trying to let it untangle. It's much better if you create some context awareness so that the language model can see the CAD that you're working with, and if an error comes up, it can immediately see that error and see what it did and fix it. And so I haven't found a way to do that with something like OpenSCAD, because OpenSCAD's not running in a browser window. It's running in its own isolated app, and I don't see any way to make a bridge between those. But there are ways you can do this with other CAD packages. So one, if you're working in any kind of graphical system that works in browser, like presumably Cindy.js, although we haven't seen that, or ShaderTour, the two tools you're going to learn about this week. Once you're working in browser, there are a couple of different browsers made by these companies that allow you to interface a language model with whatever you're looking at in the browser. So then it doesn't matter what you're using. As long as it's running in the browser, it can see it, and then it can see any error messages that come up. So let's do this example. So we can go to Chrome. Chrome is made by Google. Google makes Gemini. And I'm going to copy paste this code. So let's go over to Chrome. Here's Chrome. So here's Chrome. And what I have up right now is a Google Colab window. So those of you who are unfamiliar with Google Colab, if you have a Google account, then you have a Google Colab account. Just like you have access to Google's Sheets and their version of slides and whatever, you also have a coding environment. A lot of my students don't know this because it's kind of hidden. It's not as obvious as the other Google services, but Google provides a clone of a Jupyter Notebook, which is an interactive Python environment. And so you can immediately just, you don't need to install Python. If you have a Google account, you can just write Python code by going to Colab. And so this is a blank Colab document. And Colab is just Python. And so Python can create mathematical illustrations using various packages. Like if you're doing a 2D illustration, you could use Matplotlib as a standard Python package for doing visualizations. So the prompt here, so this little button on the top is Gemini, which is Google's language model. And if you open up the Gemini window, you can see it is aware of the current tab. You can see right over here, it has context awareness. So everything that I do in this coding window, Gemini will be aware of. So if any errors pop up, Gemini will see those errors and then can modify the code. And you can type prompts here. So I'm going to copy paste that prompt here. Write a Python script for Colab that generates a square spiral. So it's now going to think for a little bit. Uh-oh, something went wrong. What went wrong? Let's try that again. Uh-oh. Gemini in Chrome isn't available in your location. Oh, okay. Apparently in Europe, we can't do this, which is fine because we have other options. So the next demo I was going to do was a ChatGPT demo with Shader Toy, but let's do that demo too. So now I'm going to go to, let's see if it works here. Google Colab. Let's pull up a Colab window. So this is now a different browser instead of, I don't know why this is here. Oh, I know what this is. Let's see. Oh, this was a new, oops. Stop it. Let's see if they'll do it. Okay, all right, here we go. All right, so different browser. So if you're a Chrome user and you're in the US, you can use Gemini, but apparently you can't do that in Europe. So we'll try a different way. So this is a different browser. It's not Chrome. This is a browser that is about 6 months old, put out by OpenAI, called Atlas. Atlas allows you to view the web and interface with their language model, which is ChatGPT. So let's try that again. So I can, instead of a Ask Gemini button in the top right corner, there's an Ask ChatGPT button. So let's see if this one works. And again, you can see by default now, it has context awareness of the window that I'm looking at. So now I can type the same prompt. It says, write a Python script for Colab that generates a square spiral. Let's see if ChatGPT will do it. Here we go. Here's a clean Colab-ready script that generates a square spiral, plots it, and also shows the points as a pixel image. And you can see, if you know some Python, you can see it's importing NumPy, so it's going to do some calculations with NumPy. It's going to use matplotlib for the visualization. You can look at the code here. It's generating a square spiral. Okay, so let's copy this code and put it in this Colab cell. And let's see if it works first. So I'm running the cell, and it's got to connect to Google servers, and there it is. There's a square spiral.
So question, what did you tell it what a square spiral is?
I didn't tell it what square spiral was. I just said, do something. Yeah. Do it. Okay. All right. But the point is that we have some context awareness now. So I'm going to just look at this code here and just intentionally introduce an error. Where's a good place to introduce an error? I'm just going to add to this line here, add 56. I'm going to add x, and x is probably going to be an undefined variable. Let's see. So if I rerun it, oh, there it is. It's giving me an error, a type error message. And now, rather than copying and pasting that error message over, I can go back over here. And I'm just going to admit that I was dumb. I'm going to say, I copied this wrong, and now there's an error. How do I fix it? And the point is, it should. Good news, this is a simple copy-paste bug, and the error message is pointing us right to it. What went wrong? The line is incorrect in your notebook. W equals x max minus x min plus 1 plus x. So there's a plus x I added intentionally to force the error. And so now it's going to tell me how to fix it, and then if I fix it by deleting the x and rerun it, then of course it's going to work just fine. Right? So that avoids the context switching, copying, pasting the error between two different platforms, which is really inefficient. Now, we can take this a step further. So working in browser is one way, which you could do in the US, apparently with Google, with Gemini and Chrome, or you could do it here with Atlas and ChatGPT. Another thing you could do with ChatGPT and Atlas is you can let it take control of your browser and literally write the code for you. So you don't even have to copy paste the code over. It just writes the code in the right place. So I'm going to just demo that in a minute. Let's see, write a script for shader toy that creates a rotating cube which explodes into 8 smaller cubes. So Steve's going to look. Was this one of your exercises? No. Yeah, take it.
Steve, what's your homework AI policy?
All right. So here's shader toy, and now I'll ask GPT to do that, but I'm gonna enable agent mode. So in agent mode, I'm asking it to do that. So I'm going to say, write a script for shader toy that creates a rotating cube that explodes into 8 smaller cubes and insert it into the window. Now when I hit enter, it goes all pixelated. This is telling me that it's taken over control of my browser. And now it's going to simultaneously write the code, and then after it writes the code, it has to literally find the window, click in the window, delete the default code that's there, type in its own code, and then so there it goes. It's inserting final script. And at any time, you can stop it and take control over what it's doing. If you don't like the fact that it's logging onto some website and buying things with your credit card, you can stop it. I'm demonstrating this as something I consider at this point very much a beta feature. I never do this. I think it's terrible. But it's definitely the future. This is definitely where things are going, where you just don't even copy paste the code. You just tell it to write the code and execute the code, and it's done. So there you can see it did it, and it's even hitting the play button for me on the canvas.
Checking.
No, it's checking it. It's double checking it.
It's not checking because it doesn't have eyes.
There we go. I've inserted a GLSL script into shader toy, which creates a rotating cube that explodes into 8 smaller cubes. Code defines distance functions for a cube, handles the timing and explosion of smaller cubes, and uses a ray marching approach with normal calculation of basic lighting to render the scene. If none of that makes sense to you, then come to Steve's presentation because he'll teach it to us. We can, ask it now to make changes, so I can go over here and say, change the cubes. What was that? 7 cubes. Change it to 7 cubes. I'm just going to say, change the cubes to red. So now it's going to figure out which line of code has to get changed, and then modify that code for me. If any errors pop up, then it's going to see those errors and then self-correct, et cetera. Again, I consider this a beta feature, and I never actually do it in practice, but it is the future. You can see it's slow. Part of me thinks that it's probably intentionally slow so that it's human followable.
Or cheaper.
Or cheaper, yep. So, presumably, these language models work lightning fast. There's no reason it has to be as slow as what you're seeing. So, verifying red cubes. Recompile, and now.
So if you ask it to do 7, will it just do it? Because
I don't know.
Please you?
Let's find out. I want to rerun it. Compile, run. Well, there we go. I want to make sure it's actually exploding into. There we go. So it really did. I don't know. Let's see. Now make the cube explode into 7 cubes. I don't know what's going to happen. Let's find out. Oh, subs. Oh, shoot. Oh, did it? 7 cubes instead of 8 now. Yeah, let's see what happens. I don't have to update the maps function to include a skip. It skips one of the subcubes. So what did it do? Let's recompile and let's run it. Make it bigger. Oh, how do I run? Steve, how do I rerun? I know there's a button here.
The rewind button.
Oh, rewind. Oh, it just, well, it did it. It just skipped a cube. Yeah, there's one missing right there.
As requested.
This is perfect.
It even commented on one of the subcube, one cube explosion of the survive. Yeah, what was the problem?
All right, the other thing I've done, now I work mostly in Rhino. I like Rhino. I let those of you who know me know I also like Grasshopper, which is a visual scripting plugin for Rhino where you essentially build code by manually dragging a flowchart. Your code logic then follows that flowchart. But in Rhino and in Grasshopper, one of the cells of that flowchart could be something that you create by writing Python code. So that's where I've used AI in Rhino. So let me just demonstrate that real quick. So here we have a Rhino Grasshopper component. So this is Grasshopper over here. So just if you've never seen Grasshopper, real quick, I'll just do a 10-second demo here. It looks a little bit like Cinderella. You've got a bunch of little tools on the top. You've just got a lot of them. So in particular, I can make a circle component here. But now if I set the radius, and you can do this dynamically, I can make the radius, can set some sort of slider, hook it up to the radius, and now you're seeing over here in the Rhino window variable radii. And now I can take that circle and I can feed that circle into something, let's see, extrude, no. Extrusion distance, set one vector. All right, so anyway, I'm just showing you real quick how you build stuff in Grasshopper for anybody who hasn't seen Grasshopper before. So Grasshopper, ignore this box here on the bottom right for a second. I've got a circle, a little box that instructs Rhino how to make a circle, another little box that feeds that, fed the resulting circle into another little box, which is the extrusion box, which extrudes that circle vertically to make a cylinder, right? And now by stacking these boxes, and having branch logic and there are ways to create loops and do iterative designs within Grasshopper. You can then build some very, very complex geometry over here. And this is how I tend to make all of the things that I 3D print and all the illustrations that I do. And I do both 2D and 3D illustrations with Grasshopper. I do a lot of pen plotting and laser cutting of 2D designs, as well as 3D printing of 3D designs. I tend to do that all with Grasshopper and Rhino. One of the things you're seeing on the screen here, though, is, let's get rid of all this, is you're seeing a Python component. So up here in the window, I know the font is very small. Maybe it's bigger for you all so you can see it. Under the math library, that's a mesh library, under math, under script, there are different scripting components. You can have a C# component, Python 2, Python 3, Visual Basic. So this is just a standard Python component. And I've replaced the default script that's there with a little tiny custom script that I wrote with assistance from ChatGPT. What this script does is it's just a hook. All it does is it references an external file. So this is one that I think needs some explaining, especially if you don't know Python, but even whether or not you know Python, I think it needs some explaining. So what this tries to do, you can see at line 8 there, there's the word try, and then 12, there's except. So this is a little try except block. And what it tries to do is import an external Python file. So I'm about to go into Cursor, which is VS Code fork. So VS Code is a standard, any software, if you've taken an intro CS course in college, you probably wrote your code in something like VS Code. I'm going to write my code outside of Rhino, and then I'm going to import it here, and then that code is going to create geometry. But if that code fails, that's where the except line kicks in, then it's going to write to an external text file, the error log, which then I'm going to import back into my coding environment. So there's two things going on here. It loads this external file. It generates the geometry from the external file. If it fails, it writes the error log back to the place where I'm working on my code. So this creates this two-way path between Rhino and my external code editor. So rather than writing the code here that's actually going to generate the geometry, I'm going to write the code in Cursor, which is this external coding environment. And now I have this two-way feedback loop between the geometry and the error log, which is the key, the important part. All right, so here's Cursor. So if you've ever done any sort of coding, there's a good chance you've used VS Code. Cursor looks exactly like VS Code, but Cursor is specifically designed to work well with language models. And within Cursor, you have a huge variety of what language models to work with. So I've got it now set for Claude Opus 4.5, but you could use Cursor's own model, which is Composer. You could use a previous model from Claude, from Anthropic. You could use OpenAI's models, GPT 5.1, 5.2. You could use Google's models, Gemini, et cetera. So we'll just stick with, I'm trying to demo lots of different companies' models to stay company agnostic here. So we'll stick with Anthropic's Claude, and we'll ask it to write some code. And I'm running a little low on time. So I'm going to just copy paste the prompt here. Actually, first thing I'm going to do is I'm going to create the context awareness from Grasshopper. So I'm going to copy paste this hook, and I'm going to say in Cursor, I'm going to tell the language model what my Grasshopper hook is, how I'm importing the code from Grasshopper, so it sees that, right? So I'm going to say I have the following code in a Grasshopper Python component, and I copied paste the code in. And now I'm going to say I will replace my script.py with a new script called Taurus knot. Well, let's just call it trefoil. Let's just do the same demo. I had a more complex one, but I'm low on time. .py that you will write create Taurus, create trefoil, sorry. Create trefoil.py. So now it's going to think about it, and it's going to write the script. It's going to ask, it's going to say what its plan is, ask me to accept that plan, accept the plan, and then it's thinking and it's writing the code, and now I can look at the code it wrote. There it is. There's the code it just wrote. And I can now save that code and import it into Rhino and run it. And if there's an error, then that'll get written in a file that Cursor can see, and it'll then fix the error, right? I'm getting low on time, so I think I won't have time to demo all of that. But what I've done is created this two-way path between Rhino and Cursor so that it can generate the geometry and see any error logs. Let's see if I could, how quickly I could do this. I've got to commit changes, keep. Oh, didn't want to do that. Yeah, I think I don't want to do this right now, but I guess it's fine. So file, save. The question is, where did it save it? There it is. Okay, it saved it where it's supposed to be. Yeah. Oh yeah. Right. Sure. So now I'm going to go over here. Instead of loading my script, I'll load trefoil. And
30 seconds of my script.
yeah, I'll get there. Oh, there's a my script in the code.
In your writer group.
Yeah.
That's
Yep. Well, I just ran it. And I'm not seeing any output.
So you should see an error type.
Yeah, I should see the error here, cursor, and then here's where the errors are written. Name inputs is not defined. Did you mean input? I probably did mean input. So that's telling me that's my issue. Yeah, line 11, result equals trefa input. Yeah, I don't, nope. But you can see immediately the error log changed. And go back and forth. So this is an error with this hook script rather than an error with the code that it generated. If there's an error with the code that it generated, it would then fix that error. So it would go back and forth. All right, I'm super low on time, so I really want to stop this because there's a couple more things I wanted to say, just general comments. So let me just go back to here. All right, I think the big question is this cheating? So I do want to talk about that for 2 minutes. I think this is a real question. This is a real question that our students struggle with, those of you who are teachers, which is probably all of us. And this is a question for us as illustrators, as mathematical illustrators. Is this actually okay, what we're doing here? And I think that there are multiple answers to this. When I have a mathematical illustration project, and I work hard for a week, and I do that project, and it's done, and I've created this cool thing that I'm really proud of, I feel really good about it, and it took a lot of effort. And part of the reason I feel good about it is because a lot of effort to do. And so having AI do it for me does cheapen that experience. It does take that away from me. It deprives me of that feeling like I've actually done something significant here that, you know, now just took 5 minutes to do instead of took a week to do. On the other hand, sometimes I'll be doing a large illustration project and there is some technical step, there's some tool I want to build, which is not important to the entire project. I just want to create this tool that then I want to use. So some examples, and how to clearly underestimate my time. One of the things you can do with this workflow is, we just saw in Cinderella that there are some tools to do some hyperbolic constructions that Chaim was showing. So Rhino doesn't have those tools, but you can use something like ChatGPT or Gemini or Claude to create those tools. Now, once you've created those tools, then you can do hyperbolic illustrations in Rhino and Grasshopper. So that's a case where I think you're just creating the tools, and you're not, the project doesn't depend on the tools. You're just making new tools for yourself that then you can now spend a week making constructions in hyperbolic geometry using Rhino and Grasshopper. So I think that this can go a lot of ways. I think in the end, if the idea is yours and you like the output, then in some sense maybe it doesn't matter how you got it. But I think there's reasonable ethical and psychological questions here. I mean, how much effort can you need to put into it before you can claim that it's your work? I think that's something that we as a community will have to wrestle with. So that goes to Saul's question: is this the end of the world for us? All right, one more thing. I always have to end this with a plug for my own thing. I've been writing about AI weekly for about 7 or 8 months now, and I write about all kinds of stuff. I write about sometimes some of the technical issues that underpins AI, trying to help the general public understand how it works, how large language models work. But then I'll also write about some of the legal issues, some of the ethical issues. There's a post that'll come out tomorrow on this debate over whether or not we're in the middle of an AI bubble, and I've written some things about that. So I encourage you all to sign up for that. You can just type in profbachman.substack.com, or you can use this QR code to sign up. It's free, it comes out once a week, and it'll clutter up your inbox, and takes about 10 minutes per week to read. And also, I'm going to be here all week, and I like talking about AI. That's kind of all I talk about to most people. So feel free all week to just come and we'll talk about it. And if you have issues with it, that's fine. I want to hear your issues with it. And if you have ideas for how to use it, if you've used AI to do mathematical illustration work or any kind of work in some way that you would want to share with me, I always like to hear that too. So I don't know if we have time for questions. Are we done in 5 minutes, or what time are we supposed to be done?
Maybe 2 or 3 burning questions, and then sort of transition into the coffee break. But first, let's give a big hand to Dave. So any really burning questions, anything that's sprang to mind that you want to have answered at this point?
Thank you for the great talk. Question.
I'll wait for sorry.
Now we're going to make Remy get.
Thank you for the great talk. The question: which of these tools and approaches that you described are available with a basic $20 subscription, and which are available with no subscription at all?
Yeah, that's a great question. I have my college pays for me to have a $20 subscription to OpenAI and to Google, so I use those. I don't have one to Claude, but I do have a Cursor subscription, which gives me access to Claude. So for $20 a month, you get a lot of intelligence from any one of these models. You don't have to switch between them. The free subscription also gives you a lot of intelligence. I recently read kind of a rule of thumb is that the free subscriptions are roughly a year behind the paid subscriptions in terms of intelligence level. And a year ago, things were already quite good. So the real difference with the free subscriptions is that you get throttled with the amount of use. So if you use it all day long, they're going to cut you off at some point. So that's the main difference you'll probably notice. If you don't, so for $0, you can sit around and play with these, and you'll get great results with any of the models. I was going to show you. I'm gonna do one more thing. I was gonna show you one quick test I did. It's not a quick test. I really wanted to push these models to see how good or bad they are, like what the current absolute state of the art is. So I asked ChatGPT, I asked Claude, which is supposed to be the best coding model right now, to create a single Python file which generates a working pendulum clock, and it doesn't work. But it's pretty good. It's got a lot of the key elements. If you know anything about clock design, you know the gearing of the escapement wheel the teeth have to have a different shape than the shape of the teeth on the other wheels. Like there's a lot of the key elements of a clock design are actually here. The escapement mechanism doesn't have quite the right shape. The hook for the pendulum isn't quite the right shape, but I think it's shockingly close. So that's pretty amazing to me. That's like my ultimate test is, can you just ask it to make a working clock and get all the mechanics right and all the gearing right? And it's pretty close. Sorry, was there another question? Yeah. So.
How good are the models at mathematics? I mean, I know this is a conference about illustrating mathematics, but maybe I can also ask
just a general question. Yeah, they're getting better at mathematics. There's an Erdos problem list that people are constantly talking about online, because they're feeding all the models into all the Erdos problems into all these models, and it's now solved, I think, 2 of them. So those solutions are a little bit controversial because it's not clear if those solutions are somewhere lurking out there on the web and it just found them, or if they were just low-hanging fruit. And there's a lot of open Erdos problems, like several hundred, I think. And some of them, presumably, just nobody's really worked on, so they may be relatively easy. So there's some controversy over that. Those of you who missed the news this past year, 3 of the models scored gold on the International Math Olympiad. So that was a big deal, some evidence. You know, those are hard, they're high school level, but extremely, extremely difficult problems that the 2 of the models, ChatGPT and Gemini, both scored at the gold level. I think scored like 19 out of 20 or something like that. I forget the statistics. So they're good and they're getting better. I think that's where we're at, just in terms of raw mathematical ability. Yeah.
I just have a kind of a comment, a question, but you know, referring to these things as AI is something like in 1900 referring to powered transportation and like the vast number of different technologies. And you were very good about consistently talking about LLMs specifically, but I think it's important to realize that LLMs, at least as I understand reasoning, don't reason. You know, they are essentially taking an eigenvector out of all of the corpus of human text that's on the internet. And yet, we do get these amazing results. And do you know, the question of like mathematical reasoning, are those just like I've fed a bunch of IMO type problems into there, and of course those are on endless stack exchanges, has no trouble whatsoever. Yeah. Are the models that you're talking about, are those actually just LLMs, or are those something else?
That's a great question. Last year, 2024, Google scored very high on the Math Olympiad, but that was with a more custom model for mathematics. The 2 gold medal scores for this past year, for 2025, were LLMs. So that's been changing a bit. So the 2024 model from Google that scored high used automated theorem proving techniques using lean code and with verifiable proofs, whereas the more recent results were just straight up, just ask ChatGPT and get an answer. It was using a version of ChatGPT that they haven't publicly released yet, but I think the Gemini version that they used, Google's version, is publicly released. To answer the first part of your question, though, whether or not they reason, I think the fairest way to say it is they're trained on a large corpus, like everything that they can get their hands on, of human output, and they look for statistical patterns within that output, and then there's an additional layer of reinforcement learning on top of that, which adds to the problem.
It's just essentially matrix multiplication,
Yeah, this is a longer discussion. It's not.
So I think
It's not.
Let's
Yeah.
maybe at this point move this discussion over to the coffee, which is right in front of the hall, but not before or after giving another hand to them. Thanks.